You know, I can buy a bunch of gear and I can get it running, but unless I've got people, you know, you're in trouble. In particular, you've got to retain and keep those people. You need people with expertise in grid computing and scientific software. You also need people who are what are called domain experts. The problem with computer scientists, I'm going to insult some computer scientists now. By the way, one of the rules about Australia is it's unlike America, you're not allowed to insult anybody. In Australia, the rule is you've got to make sure you insult everybody so that nobody can feel left out. Okay? So computer scientists in general are interested in their own IT technology. And often what they have is what I call solutions looking for problems. So you need people instead who are very knowledgeable about the scientific domain, but also the IT domain. Time and again in different projects, we've found having those people who can be the go-between between the cyber infrastructure experts, you know, and between the end users is a vital difference. Also, people need to see cyber infrastructure as a career. So you've got to be able to keep people, retain them, promote them. So that's been a major effort for us. You know, what we've seen time and again is that efforts which are funded through universities where you do it on the back of grad student labour, I mean, almost all graduate students, I mean, both of us did, eventually you graduate, right? You know, and then all that's left is a bunch of dead software, right? Building a critical mass of full-time non-academic technical experts for service delivery is critical. You know, and the problem, I think this has been mentioned earlier, academia tends to reward research, not service delivery or collaboration. A tenure letter which said, Joe Bloggs was a great collaborator, kiss of death. What you really want is Joe Bloggs is the most aggressive, hard-driving, individual lead PI you could ever meet on the planet, right? You also need backup staff, technical depth. We think collective software ownership is really important. That's an agile development. You've got to make sure that there are multiple people that understand any product that you're actually building, that it can be supported down the track. You've got to be willing to throw software away sometimes and start over. Technology moves quickly. Fundamentally, it's all focused on service delivery, though. You know, you can worry about anything, but if you get service delivery right, you're in good shape. What are the scientists' and industry's problems? What are people's pain points? How can we work with them? So we have an active effort where we go out to the universities on a regular basis and we track current collaborations and opportunities. We talk regularly to people at the dean's level. We talk to people at the vice-chancellor's level to understand where they're going strategically. So we employ at least, I'd say, about 5 or 6 people who's literally that's their job. And if we get a call where somebody says someone's got an engineering issue or a problem, we can just send an engineer out there the next day just to sit down and talk with them. It's also important that you're working very closely with the scientists. You can't do this sort of stuff from a distance. You often have to spend a day sitting down with them. How can we work with people, modelling larger problems, undertaking cross-disciplinary work? You have to do something that's fairly professional as far as project management goes. If you're delivering on a project, typically researchers will tell you, well, this piece of software will be ready when so-and-so graduates, which just slips and slides and all the rest of it. But if you're delivering cyber infrastructure, people want pretty reliable service delivery. If you're doing commercial work, you know, industry is not going to put up with it if you simply say, well, you know, we did our best, but so-and-so graduated. Thanks for the money. The other one, I guess, is pick your target markets carefully. That's what we've found. I mean, I'll be the first to admit that we've gone down some blind alleys at times. I mean, in particular, we were working at what's called computational drug discovery, if people have heard of that field. That's this notion you can use molecular modeling and computers to find new drugs by using docking experiments. Now, in practice, it's not hard to set up a facility and people that can do that. But what we found is that the companies we were working with were startup companies. They didn't have money. They didn't want to do this. They were going to stick with traditional methods. So we had to pull back from that. Type of metrics we use, we always look at new projects and try to say, where can we use our resources most effectively? One of the first principles is, do you have any money? So in the case of institutions, sometimes it's not money. It's in terms of commitment, dollars, time. Is this important to you? Is it important enough that you're willing to work with us? Impact and sustainability. Is this something that's going to be ongoing for a long period of time? Do we have the skills to do this, or are we going to have to, hire some people to do it? Or is it a technology, someone's got some... one of the things that we don't like to do a lot of work with, we don't like the F word, Fortran. And so we don't like supporting old Fortran code. We will at times, but we figure that's not sustainable as a long-term thing. Is this something that we can be a leader in, or the groups that we're working with, or is somebody else already doing it? Right? If somebody else is doing it, what we say is, can we partner with you? Never get into a situation where you compete. Can we reuse the technology? When we do software development, we try to build what are called generic solutions. So if we built a piece of software to do reporting on hospital-acquired infections. So that was paid for. We delivered a product, but we built an engine out of it using what's called a HL7 engine that we can use to sort of set up browsers which will scan hospital data as it's going flying across machines. And so we can do other things with that now, right? So we built an engine, we own the engine. The other one is that people sometimes say, can commercial business survive along with academic research? And it can be synergistic because a web page is the same whether it's being looked at by industry or researcher. The technology is the same. There are only a handful of underlying technologies. Cloud computing, you can use it for academic research, you can use it for commercial work. You need the same project management skills, same software engineering. And the other one is if you've got a larger pool of projects, then that gives you more stability of funding. So one of the problems with academic research centres typically is you go in troughs and dips because you're depending upon one or two sources of funding. And so that means that you either got to sort of go on to half rations or tell the grad students they actually have to go and teach or do some useful work. You get into problems in academia. So the larger the pool of projects you've got, essentially the better you can respond to new opportunities. So because we have around about 40 developers, it means that I can very quickly, if a new project comes along, sort of quickly put some people onto it and then go hire up some more developers to sort of backfill. So that works for us. The only thing you've got to be careful on is not cross-subsidising. I mean, again, universities don't like to see their money going to fund evil academic work, and industry hates to see anything going into education. So just in conclusion, look, we've seen an increasing uptake, especially in Australia at the moment. I mean, the scale of investment is actually kind of scary to us because the government's pumping in a lot. What we have to do is basically they take the motto that success breeds success. When you get runs on the board with things like biogrid or remote sensing and so on, then people come along to you. It's referral basis, and then there's an increasing investment and research and investment, and an increasing return on investment. The big factor, of course, is the uptake is limited, I would say, by expertise. You absolutely have to have people on the ground who can work with the scientists to understand their pain problems. You've got to have people that can actually deliver on problems. It's no point finding a problem if you can simply say, well, that's a really interesting problem, but we've actually got nobody that's even available or faintly interested in your basket weaving problem. So it's limited primarily by expertise and the number of people that you've got you can throw at it. And it's also limited by the amount that you can put into outreach and the amount of collaboration that you can actually do. Let's see, I'm on an hour, right? Thank you.